Good afternoon. It's my pleasure to welcome everyone to this virtual workshop on sustainable aquaculture in the U.S. with a specific focus on flounder production in land-based systems. I'm John Stieglitz, Research Assistant Professor in Aquaculture at the University of Miami Rosenstiel School. And before I move on and introduce our other presenters and panelists today, I would like to thank all of you for joining us this afternoon for this online session and to recognize the current funding for aspects of the flounder aquaculture research activities at the Rosenstiel School is the Atlantic States Marine Fisheries Commission. Thank you for supporting the sustainable marine aquaculture research at the University of Miami. With a growing human population and rising per capita demand for sustainable seafood, marine aquaculture is one of the most efficient ways to meet this demand. Implementation of marine aquaculture can provide an alternative for working waterfront communities that may be traditionally reliant solely on wild catch seafood production. Utilizing sustainable land-based marine aquaculture production techniques, flounder aquaculture is a particularly exciting opportunity for coastal communities of the Atlantic States region. The presentations and panel discussion today will provide insights on opportunities for flounder aquaculture in the U.S., with the focus on how such operations might be implemented in areas of the Atlantic States region to help ensure economic resiliency of these vital working waterfront communities. The Rosenstiel School is internationally recognized as a leader in the research and development of cost-efficient, ecologically friendly aquaculture practices. We have built a global network of graduates and trainees who are now scientists, educators, and private sector professionals committed to meeting one of the world's most pressing long-term needs, which is feeding the world. This afternoon, you will hear from scientists and industry experts on opportunities for accelerating growth of the U.S. marine aquaculture industry through development of sustainable land-based flounder aquaculture production. In order to reduce the amount of background noise throughout the sessions today, all attendees are muted. If at any point in the presentations today you would like to ask a question or make a comment, please feel free to utilize the Q&A box, and our staff will try to ensure that such questions are addressed at some point throughout the workshop. Additionally, contact information for today's presenters and panelists will be provided should you like to follow up with any of them after the conclusion of the workshop. Today, I have the pleasure of introducing you to our other presenters and panelists. We have Mr. Ron Honig, the hatchery manager at Rosenstiel School and an alum of the aquaculture program. He'll be discussing olive flounder production at the University of Miami Experimental Hatchery. We also have Dan Farkas, an experienced RAS operator, project manager, and co-founder of HGH Full Spectrum Aquaculture. He'll be discussing RAS design and operational considerations. And we have Mr. Patrick Dunaway, a seafood sales and marketing expert with egg-to-plate experience and also a aquaculture alum. They'll be discussing the sales, marketing, and distribution perspectives associated with olive flounder production in the U.S. And as part of our expert panel discussion that we have following the presentations, we have Dr. Daniel Benetti, Professor and Director of Aquaculture here at the University of Miami. So without further ado, we'll get moving along with some of our presentations here today. Bear with us as we get that set up here. And so, starting off, we're going to talk about our development opportunities for flounder aquaculture in the U.S. Again, I'm John Stieglitz. Thank you for joining us here. A little background on flounder fisheries in the Atlantic States regions of the U.S. We have, a number of different flounder species. A lot of times we kind of lump flounder together as a whole in terms of talking about flatfish, but there are actually different species which comprise these fisheries along the Atlantic coast. So they're commercial fisheries which target these species using trawl, gill nets, and pound nets. And also the flounder species along the Atlantic coast are very popular amongst recreational fishermen. Very popular with hook and line and gigging. So very, a well-known species in terms of, or a well-known group of species, I should say, along the Atlantic states. But unfortunately, we see a decline. This is a graph that we put together. This is from a paper we put out last year, looking at opportunities for flounder aquaculture. And we see this decline in flounder landings. And again, this is in recent years following this data that was compiled. We have seen a slight increase in the wild flounder landings along the East Coast, but it's still nothing close to what it was decades ago. And so when we're talking about working waterfront communities of the Atlantic States region, these communities traditionally have their viability tied to the wild catch industry, right? And so as you see those landings decline, you have situations where fishermen are going to be forced to shift over to other fisheries, that sort of thing, or is there an opportunity for aquaculture to play a role in providing increased resiliency for these working waterfronts? So the idea of incorporating aquaculture production of marine species in these regions to utilize existing working waterfront infrastructure, as well as offering opportunities for workforce development and training. Right? And so we see kind of a unique opportunity here. Historically, recirculating aquaculture systems or RAS systems, it's not a new concept, but historically the cost of implementing RAS technology for producing marine fish has been economically unfeasible, right? So there have been a lot of attempts at it, but no one's actually making money on it historically. But that has changed in recent years as we've seen technologies improve significantly, and the cost of, or the price of harvested product increase as we see the wild catches decline for a number of species, particularly flounder species. We see costs for flounder going up in the marketplace. And so we see sort of an inflection point where perhaps now we believe that, yes, this is a great time for implementing land-based recirculating systems for flounder production, particularly here in the US, where we import the vast majority of our seafood. And so marine fish recirculating aquaculture system of RAS production in the US, right? There's, again, it's not a new concept. In terms of commercial production of marine fish, there are a number of existing projects, right? So Florida pompano being grown by Aquaco Farms, Bronzino at the Ideal Fish up in the Northeast, salmon, right, here in South Florida at Atlantic Sapphire. And there are multiple other projects underway for salmon, a number of projects that are in various stages of permitting for salmon throughout the US, as well as for Seriola species, right? The yellowtail kingfish or kingfish, as it's referred to. You may have heard about that in the news as well. And other marine fish species. There are some projects on the books that are planned for the US using RAS technology for commercial scale production. And so we see that this is a very exciting time for RAS production in the US, looking at the opportunities for land-based production of these species. We're not going to get into in this workshop sort of the pros and cons of land-based versus open ocean aquaculture, that sort of thing. The fact is that we need all types of production to help reverse the trend in terms of our seafood imports here in this country. And so when we're looking at species selection for us, we look at the yellow flounder and you look at the characteristics for this fish, and it's really an ideal marine fish species for land-based RAS culture. We detailed this in the publication we put out last year, so please feel free to refer to that if you have questions about this. But a number of really encouraging attributes, right? But it's not a new species for aquaculture by any means. It's commonly cultured in Japan, Korea, and China, where it is known as hirame. It has a long culture history. It started in the 1960s in Japan, can be grown at high stocking densities. Historically, it's been grown in flow-through systems, so there is some limitation there in terms of the stocking density that you can push in a flow-through system. But now with recirculating systems, as we'll be discussing today, we see opportunities to increase that. And we see low FCRs, right, between 1 to 1.2, so very efficient in terms of a species converting feed into edible biomass. And there's an established market for flounder. We're not bringing a new species to market where we have to sort of educate the consumers as to, oh, what's a flounder? Folks know what flounder is. And Whether you're marketing it in sushi and sashimi restaurants as hirame, or you're marketing it in areas along the US East Coast or West Coast, simply calling it flounder, right? The olive flounder checks the box for that and has a strong established market, as you'll hear later as we delve into some of the market and marketing details for this species. And when we compare it with other flatfish species, as we did in this study that we put out last year, we see a number of favorable attributes for this. It's a reasonably high price, market size anywhere from 0.8 to 1.5 kilos, which can be achieved in 12 to 14 months, right? We've seen that here at the university. Under colder temperatures, different feeding regimes, you may see that extend a bit longer. But again, it can be done in a shorter time frame there if you really optimize the production cycle. So when you look at that compared to some of the other flatfish species, including some of the other flounders out there, we believe that the olive flounder really has some notable advantages when it comes to flatfish production. And so I mentioned a bit about sort of the history of global production of it. Again, the olive flounder is not a new species for aquaculture. The industrial scale production began in South Korea in the late 80s. Using land-based production. You see all on the coast there, you'll see land-based flounder farms there. Using underground seawater, which they'll see steady 16 to 18 degrees C throughout the year. So this will reduce your heating costs. Again, this is more of a temperate species, the olive flounder or the hirame. This water is sometimes mixed with coastal seawater to get the optimal temperature that growers desire. And that optimal temperature typically is around 21 to 24 degrees C. In South Korea, sort of the heart, whenever you think of olive flounder production, you probably think of Jeju Island, right? So over 50% of Korean production is on Jeju Island. They have year-round production there. Fish reach market size faster on Jeju than in other production locations in the region. There are a number of reasons why that's the case that we're not going to necessarily get into here, but it's notably temperature. And there are hundreds of flounder farms on Jeju Island. So it provides about 50% of flounder consumed in Japan. About 95% of flounder exports from Korea originate from Jeju Island. And so fish from there are actually coming into the US, and distributors are still making money on that fish. So when you see that in the marketplace, you probably have a winner in terms of the species. But when it comes to wrasse, traditionally a lot of work has been done on flow-through production of this species, as I mentioned, in South Korea. But now we see wrasse construction being looked into as well for this species. Starting about last year, company Blue Gen, they're building a land base for circulating flounder operation in South Korea, targeting 1,000 tons of market-sized fish per year. And why would they shift to wrasse? If flow-through's been so successful for so many decades, why the shift? Well, they're seeing mortality rates of anywhere from 40 to 70% due to diseases, climate change, and seasonal mortality events, right? So they're implementing wrasse technology to overcome these challenges. And so we see, similar opportunities here in the US in terms of developing systems and businesses that can do this in a manner that doesn't have high mortality rates. And so here at the University of Miami Experimental Hatchery in our aquaculture program, flounder is one of the many high-value marine species that we work with here. So it's not the only species on site, but it's definitely one of the most intriguing in terms of the market opportunities for this species. And so in the US, we have our our broodstock olive flounder here at the University of Miami. We believe we have the only known broodstock of this species in the US, as far as we know. And we maintain them at about 13 to 17 degrees C. And again, Ron Honig will get into this in his presentation and discuss some of the larval rearing protocols, which are widely available as well. Excuse me. And so today we'll be covering a number of different aspects of flounder aquaculture in the workshop. We'll be looking at development opportunities for land-based flounder production in the US, We'll be looking at marine RAS system design and operation for flounder in particular. Again, flounder production methodologies from the biological perspective. How do you produce these fish, right? So our hatchery manager, Ron Honig, is going to really get into the details of that. Very exciting talk coming up, as well as some market considerations for developing US-based aquaculture businesses. Mr. Patrick Dunaway is going to be discussing that. Again, I need to include this, sort of our legalese right here in terms of this workshop. Again, being funded by the Atlantic States Marine Fisheries Commission, thanks to NOAA as well. And it wouldn't be possible without the hard work and dedication of the faculty, staff, students, and volunteers here in the UM Aquaculture program, as well as, again, the funding from the Atlantic States Marine Fisheries Commission, as well as collaboration with our aquaculture and seafood industry collaborators, some of which you're going to hear from today as part of this workshop. So thank you. You have my contact information there if you have further questions. And with that, I will stop sharing my screen and we'll move on. If there are any quick questions, I believe we can take those here.
John, there is one question. We have Antoine asking about pumping saline groundwater. What is the salinity range and optima of the fish?
Well, two different questions there, but they usually, if you're in a coastal location, if you're close enough to your water source, to seawater, you're going to be seeing, full strength salinity groundwater. Again, that's a broad generalization. It really depends on where you are. So whenever we talk about groundwater, my best advice would be get it tested, right? And get it tested throughout the year under different conditions, rainy season, dry season, all sorts of things to really be able to answer that in terms of what the chemistry of that groundwater is going to be. And we have another question from Enrique. These are all of our some alums here. This is great, chiming in. Can you give a range of stocking densities that would work in RAS? Yes, hold that thought, because we have some presenters that are going to be discussing that specifically. And so with that, we're going to transfer over, I believe, to our next presenter, Mr. Ron Honig, who at this point, I think should be able to share his screen.
Thank you, John. Let me get this queued up. How are we doing there? So thank you. Very excited to participate in today's workshop. And I'm going to be talking to you about our olive flounder.
We're not seeing your screen. There you go.
You have it?
Now we do, yeah. Go ahead and enlarge it.
Excuse me?
Enlarge it.
Enlarge it.
We need full screen.
Got it?
We're seeing your presenter mode again.
Oh, sorry about that. Let me
Quick
stop
fix.
there. Let me try that one more time. How was that?
Perfect.
All right, thank you. Sorry for that hiccup. So as John said, my name is Ron Honig. I am the hatchery manager here at University of Miami's Experimental Hatchery, where we work with a number of different marine finfish species. But specifically, we're going to talk about our production methods for the olive flounder. So one item that's been noted for inhibiting development of marine aquaculture is the lack of seed stock availability. It's been identified as a bottleneck for the industry, and that generally comes from lack of spawning brood stock, poor egg production, low survival rates from egg to fingerling. And basically, when you have limited seed stock, you're going to have limited end production. You're not going to have the juveniles available for on-growing and those farms to produce fish to get to the market. So that's what a lot of our research here is focused on how do we improve survival and production numbers on a number of different species. So it starts with your broodstock. Currently at the university here, we have a primary group of fish. You'll see in the tour later, it comprised of 17 adults, 8 males, 9 females. They are maintained in temp-controlled flow-through setting. The optimal spawning temperature for this species is between 16 and 20 degrees Celsius. They will spawn outside of that range, but that's sort of the optimal. It coincides with the optimal larval rearing temperatures as well. So the nice thing about this species, they can be cycled on and off spawning by use of temperature manipulation. So it helps you control your production cycles, basically by significantly lowering or significantly raising the temperatures outside that range. You can inhibit spawning from the fish. Our current broodstock are fed a natural diet consisting of various fish such as sardines and herring, as well as a little bit of squid. And then they get weekly vitamin supplements. The results of that are a continuous egg supply. Our fish volitionally spawn, so there's no hormone use. There's enough females in there that we have almost daily spawning when they are on cycle. Results in anywhere from 200,000 to upwards of 3 million eggs in a spawning event. Our current broodstock fish, some of them are in excess of 10 kilos. So they can produce a lot of eggs. During peak production, we've seen over 32 million eggs in a month out of this one group of broodstock. So that is enough production to support commercial scale farming of this species. So once we have our eggs, we use a couple different common disinfection treatments. Primarily, it'll be a formalin bath of 37% formaldehyde solution. You can also use a couple other different products, Ovidine, which is an iodine solution, or peroxide, which is a hydrogen peroxide solution. You want to sterilize the outside of that egg before you stock it into your larval rearing system. So here we have our larval rearing setup. Primarily, we work with 400 and 1,000 liter round larval rearing tanks. We have the ability on site to scale up to a 12,000 liter tank. We have an installation of 4 of those. Should production demand the increased volume. Tanks are set up using aeration and supplemental oxygen. We maintain the oxygen levels in the tank at or above saturation. We run our larval rearing on flow through. It's UV, it's filtered down to 1 micron and then UV treated water. We'll run an average daily exchange rate from 200% to upwards of 1,000% or more during weaning. What that means is we're turning over the tank 2 to 10 times a day with new water. Our optimal larval rearing temperature range is 18 degrees Celsius. And you can, again, raise them at higher and lower temperatures, but you need to be careful for the higher temperatures, because that will shift your production to more males. And for this species, the females grow faster. So you want to, from a production standpoint, it is more economical to grow females. So you want to watch that. Here we have just our typical olive flounder feeding regime. You'll see this for any number of species, and follows common practices of rotifers, Artemia, onto dry feed. You can see the timelines there. So rotifers usually about day 3 through day 15 post hatch, and then you wean on to Artemia somewhere around day 13, day 14. And these numbers will be, these timeframes can be shifted a little bit, a day or so in either direction, depending on your rearing temperatures. And then from Artemia, you're on to a fine flake food. In this case, we're using Otohime size B2. So we employ a green water technique in our larval tanks. And what that means is we introduce microalgae into the larval tank. So this serves several purposes. One, early on, it helps with prey definition. The larvae don't have very good eyesight. So helps the rotifers stand out for them to hunt them down. Also reduces the light stress on the larvae in the tank. As well, it can be a supplemental feeding for your rotifers that are now swimming around your larval tank. So at least for this species, we prefer to go with a algae concentrate. It's a product that comes frozen, can be thawed out and used on demand. And we'll usually maintain green water in the tanks through about day 15 post-hatch on this species, at which time, once generally transition to Artemia, it's no longer necessary. So our first live feed item is the rotifer. So we maintain these cultures here at the university in fairly high density, upwards of 2,000 rotifers per ml. And we'll do them in semi-continuous batch cultures in either 400 liter or 1,000 liter tanks. So our feeding is based on tank volume. So you may feed anywhere from 5 to 30 rotifers per ml of larval tank volume per feeding. And we usually do a 3 to 5 feedings a day. So we'll harvest our rotifers. You can see in that upper right-hand picture there, that's our harvester full of newly enriched rotifers. We'll enrich them for about 24 hours with various commercial products that I'll show in the next slide. And we rinse them with UV sterilized water. We want to provide a nice, clean, enriched rotifer to your larval fish. You don't want to pass along any bacteria in the process. So once you've cleaned your rotifers, we will cold store them for use throughout the day, generally down to about 10 degrees Celsius. And you can hold them in cold storage for up to 24 hours, but we tend to use them on the day they were harvested. Some standard water quality parameters for your rotifer culture tanks. I will just highlight here the importance of temperature and oxygen. When you're running these culture tanks at really high density, you need to provide supplemental oxygen to maintain levels above saturation. Otherwise, you will most certainly crash your cultures. Also, another thing of note is temperature. While the temperature range has a wide temperature range of survival, at the lower temperatures, your populations won't grow very well. So if you're planning a production and you need a certain number of rotifers to feed your larval fish every day, you need to be aware of seasonality and what temperatures are running in your rotifer culture to meet your demand. As I mentioned, some of the commercial products that are available, we've used all of those in our facility. You will have to see what sort of best suits your needs with your staff and your species and your facility. Currently, we've used Ori 1 on our last production, but they all are excellent products that meet the nutritional needs of marine larval fish. On to the next stage. It's your Artemia production. Similar process with the harvesting as a rotifer, cold storage. With, however, it's a little bit easier step. You hatch out cysts in 24 hours, and then we enrich them for another 12 to 18 hours before feeding them to our larval fish. And in that initial transition from rotifers to Artemia, we'll usually do a day or two of feeding the newly hatched Artemia before moving on to an enriched one. Again, you can cold store them at 10 degrees Celsius for up to about 24 hours. Again, the larval tanks are fed at concentrations per tank volume. So we usually do 0.01 to 3 Artemia per milliliter of water. standard Artemia culture parameters here. Again, I would highlight the importance of temperature and oxygen, especially once you go into an enriched Artemia. The need for significant supplemental oxygen is there as those fish consume the enrichment and metabolize it. There's a great oxygen demand, and they're in static cones, so generally about 500 liters of water. And then when you look at the temperature, again, similar to rotifers, but with Artemia, you have a set hatching time. Generally, we plan on about 20 to 24 hours for the cyst to hatch. But if you have a cold front, the tank water temperatures drop down, that can run 26, 28 hours and throw off your production cycle. If you're planning on having all of your hatched Artemia ready at 8 a.m. and your temperatures are down and they still haven't hatched by 10 o'clock, you have no feed for your larvae. So you need to pay close attention to that. A product we like to use in our facility, it's called the Separt by Inve. These are cysts that you buy, and then the separator is in the center picture there, that blue tube. Basically, there's a magnetic coating on the cysts and industrial magnets within that blue tube. So any unhatched cysts or any of the shells from the hatched Artemia are easily removed from your end product during the harvest technique. So you run it through that tube, and all that comes out is nice, clean Artemia. So that helps reduce passing on any sort of bacteria that has colonized the hatched and unhatched cysts. Next stage, sort of the final stage of the larval process for these flounder, they go through metamorphosis, and it generally coincides with weaning them off of your live feeds, your Artemia, onto a very fine micro diet of flake food. So this is a critical period. You'll see significant increases in larval mortality during this stretch. So when you put the dry feed in there early on, not very many fish are eating it. So the vast majority of it ends up on the bottom, where it is a very good substrate for bacterial growth. And then at the same time, your fish are transitioning, their eye is migrating across their body to be on the left side of their body, and then they go settle on the bottom down in all of that detritus. So it's important for siphoning, skimming, and overall cleanliness of the tank at this period. At this time period, we'll increase water exchange rates and aeration. So once these larvae are sort of post-metamorphosis, it's a good time to move them. So now you can see in the lower right-hand corner there into a raceway style system of sort of pre-nursery tanks where you have more surface area for them to settle on the bottom. Also at this time, it is a good opportunity to do size grading. You will find a distribution of sizes, especially in high density, where now you'll have some extremely fast growing fish that will end up cannibalizing a good number of your production. As I mentioned, the weaning diets that we like to utilize in our facility, that this is a very important to have a high quality diet, something that's easily digestible, that also has good attractants in it, so that you're transitioning, you're trying to get this little larval fish to go from eating some sort of natural plankton that's swimming around to a flake food that just sort of sits there in the water. So we utilize Otahime, also Skretting makes Gemma, and the Sango product by Higashimaru are also options for this species. So as mentioned, now we're through, in this metamorphosis period, and weaning, you have to sort of pay close attention to your larvae. It's a critical point where they could be exposed to pathogens, both bacterial and parasitic. So microscopic analysis of, a subset of your larval population every day to assess that, if there's any concerns that need to be addressed. You can see in the lower right, in the green circle there is an amylidinium cyst on the fin fold of a sample. So fortunately, good filtration can eliminate a lot of those concerns, but you need to be aware of that. Once you're with this species through about 5 or 6 weeks of production, mortality really drops off. You'll have a weaned fish that is, settled on the bottom and ready for on-growing. Now, we've got our juveniles. We have shipped some of these around to growers. You can see we've got our team in the middle there, packing them up in insulated cardboard boxes with a styrofoam insert. We usually do about 30 liters of water per box, ship them in 5 to 10 kilos of fish biomass per cubic meter at about 10 degrees Celsius. And there you can see on the right, our bags of fish acclimating in their new home. So I just want to sort of wrap up and highlight some of the larval rearing metrics we see in our facility here. We have consistent egg supply, both in frequency and quantity. Through the larval rearing process, high survival rates. We're seeing 40, 50+% survival in a larval rearing. And the nice thing about this species, it does not require a huge amount of larval rearing tank space. We produce in excess of 35 weaned larvae per liter of tank water. So to put that in perspective, when we do larval rearing in a 1 ton round tank, we will end up with 35,000 35, 40-day-old fish. So we have the capabilities of producing tens of thousands of juveniles per rearing. And you'll see a juvenile reach about 1 gram in 60 to 70 days, at which point you can ship and potentially even ship them earlier. On the juvenile grow out side, again, this species has exhibited high survival rates as long as, systems function the way they are supposed to. There isn't a lot of natural mortality at this stage. We have pushed stocking densities in excess of 50 kilos per cubic meter, and in some instances, even taken them over 100 kilos per cubic meter in grow out at our facility. As was mentioned, this fish exhibits a great food conversion ratio of about 1 to 1.2. And that means for every pound of feed you're putting into that fish, you're getting about a pound of growth. And we are seeing these fish reach about 600 to 800 grams in 10 to 12 months of grow out. I want to thank all of our staff and students here at the University of Miami Experimental Hatchery. Without them, we wouldn't be able to do this work. Also the funding agencies, NOAA and the Atlantic States Marine Fisheries Council. And we'll put it to any questions.
This question was from earlier, so you might have answered it, but what about waste management, and also what are the flounder fed?
All right, our flounder, our broodstock are fed, as I mentioned, a natural diet of various fish species, sardines, herring, and then we give them a little bit of squid. And then on the grow out side, once we wean our juveniles onto a dry diet, we'll maintain them all the way through on a commercially prepared pellet diet. So depending on which system they're in, our wastewater goes to an injection well on the site. Well,
Okay, well, thanks so much, Ron. It's very informative. It looks like there's another question here, if you want to field that. Enrique is asking if there are any handling issues through grading.
no, this fish species is very durable. You do have to, obviously rough handling is going to put some stress on them. You could end up with a little bit of fin damage. So, but for the most part, we aren't seeing any mortality, any the fish don't go off feed or anything like that when we handle them.
Okay, so without further ado, thanks so much, Ron. We'll move on to our next presentation. I'll introduce Mr. Daniel Farkas. Dan's an experienced RAS operator, project manager, and co-founder of HTH Full Spectrum Aquaculture, currently based in Jensen Beach, Florida. And he can tell you a little bit more about himself and take it away from here.
All right. Well, thank you, John. I really appreciate it. I want to thank everyone for putting on this webinar, and yeah, looking forward to sharing a bit more with you all today. All right, so I'm going to be talking a little bit about the RAS design and operational considerations. Again, my name is Dan Farkas, co-founder of HTH Full Spectrum. We are a full service consulting, engineering, planning, and also a construction and commissioning co-op based out of Jensen Beach and Zirconia, North Carolina. And yeah, without further ado, let's get into it. Okay. All right, so flounder in research, right? Starting from the basics, what is RAS? RAS is an aquaculture production system that utilizes specialty water treatment components to rear an aquatic species. In this case, we're talking about flounder. And at the same time, those components have a goal of maintaining an optimal environment for the fish, as well as recycling the vast majority of the water you're using. This is in comparison to some other types of aquaculture, such as extensive, your typical pond or green water systems, or even a bit different from traditional intensive farming systems, such as a flow through or open system, as well as a traditional net pen. All right, so when we are talking about advantages of flounder culture and RAS, the guys have mentioned a few of these items already, but one of the things that we look at is in the RAS design and facility footprint. One of the first things is because of the raceway design and the way the flounder utilize the water column, we can look at a stacked production facility, which allows us to really minimize square footage in an RAS configuration. Again, one of the other main drivers is that flounder exhibit rapid growth and have an economic FCR. I put 1.2 to 1.5. One of the themes you'll see here is when we look at design and operational modeling, we don't always want to use the best case scenario, right? We want to use some conservative estimates in order to not design something or plan something that is going to immediately fall short. So some of the stuff you'll see might be a little on the higher end or lower end, depending on what we're talking about, than the previous presenters. But that's why when we're building this into the design capacity of the systems. And they also have a relatively wide acceptable temperature range, which when we're talking about RAS design and the first factor being site selection, we want to obviously try to site this in an area that does not work too hard against you when it comes to things like heating and cooling and power consumption. So that is a factor. All right, continuing on. Some X design considerations. What I mean by this is, as outside of the RAS and infrastructure designs, one of the first things that we talk about with people looking to start a farm is the site, right? You have your business plan, you know what size your farm is going to be. Now you need to find a site. And arguably finding a location for an RAS facility is just as tied to the chances for success as it is for a traditional net pen farm. So, if you site this in the wrong spot, right, you're going to have problems from the outset potentially. So we want to ask, is the site feasible from an operational standpoint, right? Is the permitting environment favorable? Is there is the site somewhere where you're going to be able to attract a qualified and appropriate number of staff members? What existing baseline infrastructure is there in your site that you are selecting to grow this farm and grow this fish? So, and is the site financially feasible? What is the proximity to market? Again, we're going to hear a lot more about the market from Pat Dunaway after me. What is the location's energy costs, right? One of the I won't say downsides, but one of the other sides of the coin for RAS is its energy usage, and that is often touted as one of the potential downsides. But systems are becoming more energy efficient as the industry continues to mature. And staffing, right? This ties into site selection, but it also just general RAS design. You want to find highly trained and experienced operators. These people are going to be the ones who not only operate your farm, but they're also going to potentially work at training your staff. And will your site be able to support them long term, so they're not just doing this job for several years and then moving on? You want to look at human capital and staff retention. All right, some more general biological considerations here. One of the main drivers when we're looking at sizing a farm and establishing the feasibility of a species for RAS is, what is the maximum rearing density that the species can be grown at? We used a conservative model number of 55 kilos per cubic meter at time of harvest. I know that commonly we are seeing, and has seen, results significantly higher. But again, like I mentioned, we want to use a design threshold that is not necessarily only going to work at the upper end of that density scale. And also, one thing to consider is the densities within the facility and the actual production modules may change slightly in different units. So for example, pre-nursery versus nursery compared to grow out, you may have different design limits and biological limits of density in each of those subsystems in the research facility. All right, some system design considerations. The RAS design should be specific. I know that sounds strange, but obviously if you are going to start and build a flounder facility, you want the RAS system that's going to support those animals to be designed around flounder, right? So you're not just going to go and point and pick an off-the-shelf RAS solution. You're going to want something that's tailored to your species at your site and for your specific business plan and sizing of the farm. The design should be scalable, right? We want the design to be able to be retained for the most part. You're always going to learn and things are always going to change and you want to be improving, but you are going to want to be able to replicate or scale up as you grow the business, and you don't want to drastically change design from one phase to the next just to maintain ease of operations for your staff and for just the operation as a whole. The bigger is important, but it's not always better, meaning this is still a new industry. Scale doesn't fix everything. It typically just makes the issues encountered more expensive. There are a lot of common issues that are still being addressed as this industry marches towards a larger production footprint in the US and a larger, let's say, margin of profitability, right? We're still looking at a young industry that is really still cutting its teeth in some ways, but is very close to really turning the corner. But that means that large farms may also encounter the same problem that your proof of concept may have. So just something to be mindful of as you look at modeling and what size business and RAS facility you may want to design, build, and operate. Just be aware that some of the problems still transcend all of those different, facility sizes. So scale doesn't always fix it. Additional system design considerations. These are basically some baseline values that we used for this model that we're going to look at in the next couple slides. This isn't the only zone that you would want to design your flounder facility to necessarily. There may be circumstances that will push and pull these values. But this was what we used for our specific example and the two sizes of capital and operational budgets. So yeah, we want to look at what's the retention time, how fast is your turnover. That's going to drive and help you with pump sizing, tank sizes, your filtration sumps. We want to look at what is the appropriate total ammonia nitrogen level for biofilter sizing, as well as system turnover. We want to look at TSS for what mechanical filtration you're going to use, an RDF or an RBC, like a drum filter or a biological contactor. We want to look at the target pH for obvious reasons. We're going to be sizing the dosing system based on that pH, as well as looking at the amount of degassing column sizings. Protein and fat assumptions. I know there was a question earlier regarding what are they fed? This actually goes in and starts at the beginning because we need it for biofilter sizing as well as mechanical filtration. It is an extremely important question, so I was glad to see someone asking that. What's the maximum feed rate for any automated feeding? What's the target temperature? Ron mentioned, as John did as well, temperature is important, and keeping this species in the proper temperature range is critical. And there was also a question on salinity. So we want to make sure that I put a range here. We obviously are shooting at the higher end, closer to full strength seawater, but that's also going to drive where your site's located, how you're sourcing your seawater. Are you dosing? So are you making salt? So that's a really key parameter as well. And what's the target survival? I put 85 to 90%, just as a baseline for number of juveniles being purchased, and after grading and normal mortality, what your sizing will be on the back end in terms of number of fish out. And again, one of the other very important considerations, what's the grow out period? All right, we used 12 months. We saw 10 to 12, but we used 12 months for the model, reception around 2 grams into a pre-nursery system, and harvest close to 1 kilo, 900 to 1,000 grams. All right, I went through, based on those inputs, we went ahead and modeled 2 scenarios. Again, these spreadsheets are hypothetical, but they are realistic, meaning this is for this scenario only, and these numbers will obviously change as the scale of your farm and the unique conditions of a flounder farm somewhere are obviously going to change these requirements. But what we wanted to show was some baseline CapEx highlights. So your FF&E CapEx, which is the top line, will basically, what I mentioned was it'll depend a little bit on the methodology, meaning how much of it are you building in-house? Are you subbing out? Are you having a third-party RAS designer build most of it? This will have a large impact on that FF&E component. And also, in this, what I'm going to call the smaller scale size, one of the advantages to the smaller proof of concept level baseline farm such as this one, well, it'll also allow you to have a jump off point to the next slide, which I'll show you, where again, like I mentioned before, you're going to learn some lessons, but these lessons at a smaller scale can be less costly and can be overcome, and solutions can be brought about a little easier than as you step up into, like, let's say the next CapEx model we have. The other side of this is I went ahead and built a 500 metric ton example to show that while the value increases quite a bit, as you can see on the bottom line in terms of capital requirements, you start to get the advantages of economies of scale as you get into this 500 ton plus range, where you can see we're producing 5x the volume, but the capital requirements are not necessarily 5x the initial amount. So you're typically going to have a little more margin of error on these larger sites in terms of OpEx and CapEx, versus if something is missed or omitted on the smaller farms, that from a percentage standpoint can really throw the CapEx budget and OpEx budget far out of whack. And on the other side, I know these details are small. I apologize, there's a lot of data there, but it was not necessarily put there for the drill down. What we wanted to show was that, you know, in a 2-year operating cycle from 0 to 2, using a $8 a pound farm gate price per pound, that after and within year 2, you may be able to see a profitable and cash flow positive farm. I know there's a lot of talk about, you know, at what point is too small versus, you know, what farm then goes from proof of concept to economically viable. We used around 100 ton because, again, without manipulating the numbers in terms of trying to be too conservative or too aggressive, we came up with a realistic, what we thought was a realistic estimate for when you may start to see significant profitability. But that's not to say that a 50-ton farm could not be profitable. This is just, in this scenario with our inputs, this is what we ended up with. And again, just like CapEx, we ran a 500-ton sample from an operational budget. We had some assumptions change, obviously, with the price per pound dropping as you're not approaching a commodity, obviously. 500 tons, 1,000 tons, you're still not in the, you know, salmon market type of fixed prices, but you are going to be going to a wider number of distributors, and you may see your price typically decrease as your scale increases drastically. Not always the case, but we like to model it in to show and prove that as you scale up, these farms can still be profitable as the price comes down with increasing scale. So in addition to that, we also want to mention that in the scenario of 500 tons versus a 100 ton, as your potential profit margin gets slightly larger with economies of scale, it will also allow you to potentially have a slightly bigger, you know, cushion or operating margin. Again, this is hypothetical, but in a farm that is barely operating in the black and cash flow positive, there is often not a lot of room for error, for hiccups, or for things that, you know, typically can and will happen in a new RAS startup. So what we mentioned, and I always use the term paper fish, right? You know, paper fish never die. They always grow to plan or better. They only eat what the theoretical values are. But as we all know, in this industry, that's not always the case. So, you know, we want to, again, as I mentioned in the beginning, we want to model things that we think are realistic operationally, realistic financially, and will give you a longer in the long run, a better chance for success. Because again, if you just build your spreadsheet and build your business to run only when things go perfectly, you might be up for some disappointment unless you're extremely lucky. So with that, I'd like to again thank UM and Rosenstiel for putting on this webinar, as well as the Atlantic States Marine Fisheries Commission and everyone else on the call, as well as the other presenters. And I'm going to go ahead and hand this off to Pat Dunaway.
Thanks so much, Dan. That was great. If there are any quick questions that anyone has in between, I think we have time for one or two quick questions before we get into our next presentation, but I don't see any in the Q&A right now, so we can go right into our next presenter here, Mr. Dunaway, a seafood sales and marketing expert with egg to plate experience. He can tell you a little bit more about himself. And with that, you can take it away, Patrick. Thanks.
So Patrick Dunaway, I'm gonna share my screen here. You guys, everybody see that? So I've been selling and marketing high-end aquaculture species for about 10 years now. Started at started with the species cobia, and that's what I do. I introduce new species to the market. I build go-to market strategies for RAS companies and other aquaculture operations, and do market analysis for them. I mean, one of the things that you see people do is, Dan went through the whole process of telling us, how much these things cost, and shows you the whole spreadsheet, the CapEx, what it costs to build this thing, what you're going to sell it for. And what a lot of people fail to build in is the cost of selling and marketing these fish into their spreadsheet. So that's where I come in. I help build that part of the spreadsheet, of what Dan would call the paper fish. And it's important to do that before you build the site, so you fully understand what your costs are going to be to get this fish to market and potentially even build a market for this. So I'm going to focus on, this is market considerations for developing a US-based aquaculture business. And I just want to thank, everyone supporting this, Atlantic States Marine Fisheries Commission, University of Miami, and all the presenters. I mean, you guys grow the fish, and then now we got to sell it. And that's really where we make the money, is in the sales and the marketing part. You can grow as much fish as you want, but if you can't sell them, it doesn't matter. So, what to consider. I mean, who's your competition? What's the sizing and specifications that are currently being sold on the market today? What's the pricing, the supply out there, and the demand, not only today, but in the future? What are the rules and regulations out there for selling the particular species you're growing? Some species have really strict regulations, say like a sturgeon or a striped bass. And then what can you do to improve the quality of your product so you can sell it for a higher value? And then sales and marketing, do you really need this? So the competition, who and what is the competition? You're growing fish. So you're competing with every other fish out there on the market. And in particular for flounder, it's any flatfish potentially is competition for you. There's only so many mouths to feed. So it's really important to understand what all these other fish are selling for, what their sizes are, and what's the size of the fish that you're going to grow, and where does that match up and compete? Who's competing it? Who's growing the fish? Where is it coming from? Where do you have an advantage? What are their strengths and weaknesses? Are they growing a larger fish and you're growing a smaller fish? And where does that put you in the market? Because if they're growing a 5-pound fish and you're growing a 2-pound fish, you may not be competing with that olive flounder. You may now be competing with sole or another species of flounder in the marketplace. So there's just a few of the different species out there. Turbot, Senegalese sole, olive flounder, some Atlantic halibut. And then there's the different production methods. I mean, they all have their pros and cons and their benefits to flavor, texture, a number of different things that can be considered strengths and weaknesses, as well as their sustainability ratings. So when you look at it, I think, John mentioned this, that the fishery is, and I did it from the year 2000, but if you go back to 1950, it really shows as a decline. And I put on here, this is what the Atlantic states are all catching right now, the percentage of their catch in compared to the rest of the country combined in flounder landings only. So 42% right now. So it's going down and it's been dropping. So there is a pent up demand, both recreationally and commercially, for the fish. And when you talk about olive flounder production in particular, I've excluded China from here because the data from China is not always right. They just say left eye flounder. So what is that? So really the two main places that are producing and importing into the US are Japan and Korea. And it's grown a lot since the year 2000, but it's remained relatively stable up until 2020. So these are the things you want to consider before you go out there is who is your main competition. And right now in olive flounder production in particular, it is Korea is your main competition out there. And that's what's on the market today. And when you look at it, olive flounder compared to all the flatfish being produced in aquaculture, it's relatively small. But it is being produced. It's possible to produce these fish. We know it's possible to produce them. It's just not being done in the United States. So that's what we want to achieve here. Bring fish to the East Coast, grow fish on the East Coast, and sell fish on the East Coast and sell it at a high value. And when you look at it, it's 26% of all the flatfish being farmed in the world right now is olive flounder. Atlantic halibut's 1%. I mean, it takes forever to grow that fish. The left eye flounder could be built. It could be some of its olive flounder that's mostly produced in China, and same with right eye flounder. And then there's Senegalese sole, which is a new species being grown in Iceland and Portugal and Spain. So it's growing. So really, sizing and specifications. This is like really, really important. We all think that the fish are going to grow out to the same exact size each time, right? Every fish is going to be the same size. They're all going to be worth the same amount of money. And that's not true. Your smaller fish are generally going to be worth less money. Your medium-sized fish more. Your big fish worth a lot more money. And you can decide to grow a bigger fish, but that's going to cost you more money. And the higher the price, the smaller the size of the market. So when building a farm and you want to do 100 metric tons or 20,000 metric tons, you plan to grow really big fish, can you sell that amount of fish on the market? And what is really being sold right now? In olive flounder, most of it, and the majority of the sales are in the Korean and Chinese and Japanese market. They're larger size fish and they're mostly live haul business. So that means they're taking the fish live, shipping them from Korea to the United States and putting them in a retail setting live. Say at H Mart would be a great example of this. You could go to almost any H Mart in the United States and see a live olive flounder for sale. And I think the last time when I looked, it was $24.99 a pound for each one of those fish. So you're talking $160 for one single fish live. And what sizes and specs are ideal and why. I mean, if you're growing a smaller fish, you're competing against a different flounders. So you got to take that into consideration on who you're competing against and what species you're competing against out in the market. A medium-sized fish, and you're going to have all three. So you can hit all those different markets. You can sell the bigger ones to the Korean live haul. You can get the medium-sized fish into the food service sector, and you can take the smaller size fish and put those into the retail sector because they'll have a lower price. So those are all, you'll have all these sizes of fish available to you. But you need to find out what is the ideal size and why you're going to move forward with that size. And really, pricing, supply and demand. You want to look at, where the fish is now today or was and where it's going and how it's fluctuated over the years and what the future holds in terms of production. If there's a massive amount of production coming out, like for example, I think cereal is a really great one to look at. Japan has plans to produce 100,000 metric tons more cereola by 2030 than it does today. And it's already the largest producer of cereola on the planet. So how is that going to affect supply and demand? And fish in particular is very much affected by supply and demand. And you can see it on a daily basis. The more supply there is, the lower the price is, especially if the demand stays the same. So you need to build and create demand for your species. As this is, basically just showing us there is a market for flounder, and it is, can go from a very low price to an extremely high price on the market. And as a farm-raised species, you can bring a lot of value to your fish and get a much higher price. So you can be in this $30 to $34 range. And that's what you want for an RAS production. I mean, you're going to be able to produce fish consistently. You can produce a more consistent quality, and you can do things that the wild fisheries can't do, like ecogeme the fish and create extra value on it, as well as create a story. And I'll talk about that in a minute. And really, considering your rules, regulations, and quality enhancement. I mean, what are the rules and regulations around the particular species you're growing? If it's histamine producing fish, you have to be very careful with time and temperature. If it's, you have to have, if you're going to process your fish in-house, you're going to have to be HACCP. And then if you want to get into retail, you got to have other certifications that retailers are now requiring, like SQF or ISC 2200, to really get into those bigger retailers and sell higher volumes of fish. And then, what are the risks? I mean, RAS is in development, and there's still some risks in terms of taste and texture that come along with producing fish in RAS. And from what I understand, and I'm sure John and everyone can speak to this better than I can, is there are solutions to these, and you can also improve the flavor of your fish by finishing diets, by handling them a certain way, by using ecogeme. There's a good picture of that right here, to clear out the blood of your fish, and that will add value to it, and not only add value in terms of the taste and the texture, but it's going to make it last longer. And 3 extra days on shelf life for a product is the difference between making and losing money in seafood. A lot of money is lost because of shelf life. So if there's a delayed shipment, and there will be a delayed shipment because of weather or any other issues that may happen, and they will happen, now you can wait an extra day, and the value of your fish isn't going down dramatically because it's waited one more day. And really another thing to consider is, this fish is flounder. So we gotta get people requesting olive flounder. When you go to the grocery store and you see flounder, it's not necessarily sold as a specific flounder unless you're in more of a specialty retail market. It's just flounder. So they could use any one of these species. And the idea is you need some marketing money and money behind it to get the consumer and the chef and the retailer asking for olive flounder and asking for your olive flounder in particular. So sales and marketing, I mean, do you really need it? Yeah, you definitely need some sales and marketing. And you're not necessarily going to just take these fish, grow them, and immediately go into the live haul market for the Korean market necessarily. You can, and a portion of your business will go there, but you won't capture all of it. So you need to build demand and build a brand around it and build a story around why you exist, why you're here, why you're more sustainable, why your quality is better, so you can get a higher value for your fish in the market. And it costs a lot up front in terms of building a marketing budget. There's a lot of money that needs to be put up into it up front. But once you have it established, then the cost gets lower and lower because you don't need to keep feeding it as much as you would in the initial stages of launching your farm out onto the market. So really, and the other thing to consider is, how is your fish currently perceived by the market in terms of its culinary application? So all of flounder right now is really only viewed and used as a sashimi application, and that's both in Korean and Japanese. The Koreans do very long, big, thin slices, and the Japanese do very thin slices, and that's a great thing because the thinner you slice it, the less that piece costs, and the more money that chef or retailer can make off the products they're selling. And do you need to create a new market beyond the existing market? And I believe you do for olive flounder. You need to get people ordering and asking for olive flounder directly. And that takes changing perceptions. And to change perceptions, it takes marketing and takes brand ambassadors. It takes chefs using the fish in different ways, and cooking the fish. And we really need to get people to view it as something that isn't just a sashimi fish. It's a fish you can cook whole. It's a fish you can, at a certain size, you can fillet and cook it in multiple different fashions. And that will get people to eat more of it. When you go into a cooked application, the volume you're able to sell is higher because they're serving more per dish than they would in a sashimi application or a sushi application. And that changes like how you approach the market, how much money you're going to put into sales, marketing, and your distribution strategy, and the budget you're going to create in your marketing budget. If you want to penetrate the market very quickly, you may want to spend a lot of money in your marketing. If you want to, slow play it and be humble, which I suggest you do, you have a smaller marketing budget and you get a really good sales team that can go out and push this product. And at 100 metric tons, that's very achievable. When you get up to 2,000 metric tons, you're going to need to put a lot more effort into marketing and go trying to get this fish into retail. And then lastly, you have to build a story. Why do you exist? Why are you growing these fish? People buy stories. They buy, and that's the value you bring. They buy your story. They don't buy the fish for itself. They buy what it represents. And that could be something cultural, which is what it is today. In the Korean and Chinese, in particular the Korean, it's a cultural, significantly cultural fish. But we can build a story that gets people to buy it. That's why the granola bar has a story. A specialty beef has a story behind it. All these fish have stories of why they're here and why they're existing, and the consumer wants a story. We buy a story. That's how we live. We live through stories. So what is your story? And start building it now before you build your facility and decide to go sell the fish. So start at both ends. Build your marketing strategy and your distribution strategy at the same time as you're building your farm. Don't build your farm first and then figure it out later, because those two things are going to dramatically affect each other on how much revenue you can make in the initial years. So I'm going to take any questions if anybody has any of them. I'm more than happy to answer them.
Yeah, we have a few questions. You might be able to answer these, but they came in just after Dan finished earlier. So the first one was from Charlie. In your scenario, did you purchase land or lease? So that might be specifically for Dan.
Yeah, in that scenario, that is a purchased option in the 500-ton scenario. In the first one, the price between a long-term lease as well as a purchase for the smaller property was close enough that it didn't drastically affect the model. But for the larger one, yeah, we're looking at purchase land.
Okay, thanks. And then we also have that came in after yours, Dan, what was the type of RAS system considered in financial modeling? Was it rectangular, mixed cell, round tanks?
Yeah, we're looking again, as I mentioned, we're looking at a stacked raceway operation, but we are also looking within those. One of the ways we designed and are helping to operate the small demonstration unit is with mixed cell within those raceways. So that is how we currently set up the small RAS unit at in the larger on-growing tanks, not the smaller blue ones that are pictured, but the larger raceways. I think you had some more questions there.
Thanks so much, Dan. Yeah, it looks like there are a few other questions here that I think these are aimed at Patrick's presentation. Can you see those there, Patrick?
Yeah, are there restaurants serving in Miami already? And the answer is yes, there are restaurants serving in Miami. I don't know those exact restaurants, but if you go to a high-end sushi restaurant, more than likely they're going to have harame on the menu, and that's what it'll be called. It'll be called harame. So check it out. Also, Korean higher-end Korean restaurants will also be serving this fish. I'll look some up. If you wish to contact me afterwards, I can definitely find you some. That's not a problem at all. And then what are some of the difficulties of sourcing skilled workers to perform ikejime? Are there automated technologies available? So the skill it takes to ikejime sounds like a really super fancy thing that takes a ton of skill. It doesn't. It's a relatively simple process. It just takes some time and a little bit of training, but any filleter could pick up an ikejime and figure it out in 20 minutes. It's not a super technical thing. And there are automated technologies available, but those are mostly for the salmon industry. And it's a basic stunner and bleeder. When you look at like the cattle industry, right? I talked to a guy, and I shared his Instagram story on one of my slides, who's doing the Ikejime Federation. He's trying to get fishermen and farmers to adopt Ikejime because of the extra value that it brings. And when you look at the cattle industry today, they're pretty much Ikejime every single animal. It's all killed a standard way, where they're stunned and bled. And of course, there's another step to this. That's the shikajime, where they take the cord and run it down the spinal column of the fish. And that's the final and the most difficult part of the process. The ikejime is simply just the spiking of the brain and the bleeding of the fish. But you can take these things out farther and farther, where you can take the wire down the spinal cord and stop the fish's nervous system from working after it's dead, which will also improve the quality of the fish. So there are automated technologies available, not yet for flounder, but when you build it, they will come. So that's all I have to say.
Thanks so much, Patrick. And so we're going to have a quick virtual tour here of the Flounder production facility that we're going to queue up now, and then we'll move into our panel discussion immediately after that. So let's get the video going here briefly. Hello, welcome to the University of Miami Experimental Hatchery. Today we're going to be touring our flounder production facility. Let's start with our broodstock tank, which you see here. This tank is stocked with broodstock olive flounder that are maintained here for maturation and spawning purposes. These fish will spawn on a regular basis in this tank and will produce floating eggs, which are collected in this egg collection tank, as you see here. Following the spawning event, the fertilized embryos will be collected and then transferred to our larval rearing tank systems, one of which you see here, for the larval rearing process. This system is set up in a way that's maintained in a replicated manner that allows us to conduct experimental trials aimed at optimizing production of this species during the early life stages. We also have larger larval rearing systems on site that allows us to produce commercial scale quantities of seed stock for the industry, hundreds of thousands of juvenile fish per rearing run throughout the year. These fish, the larvae, will spend 30 to 45 days in the rearing system, after which they will settle and be weaned and be ready for transfer to our nursery system. The advanced nursery system is a recirculating aquaculture system, or RAS unit, that allows us to maintain conditions for the fish throughout its life cycle at an optimal level. Optimize growth, production of the fish, allow for a very efficient production process. The juvenile fish will be stocked in this system and can be grown at high densities in the recirculating system to allow us to produce significant quantities of seed stock to service the industry, as well as take batches of fish out to market size. As you see here, these fish in this tank are anywhere from 1 to 1.5 kilos in size. It allows us to work with those market size fish for research purposes as well in the system. In the back portion of the system, we also have upcoming generations of broodstock fish which are maintained that are part of our flounder breeding program that we have here at the University of Miami. Thank you so much for joining us today to tour our flounder production facility. Okay, so that was our virtual tour of the facility. I hope you enjoyed it. And with that, we'll get our panel discussion started. Ron Honig will help moderate the discussion, lead us off here. If everybody, all our panelists could turn on their video screens, and Ron will get us started here.
All right. I'd also like to encourage the audience to keep posting questions and answers you'd like to have discussed during the panel. We will try to feed those in as we go. And Pat, if you can join us on screen here. I'd like to direct the first question to John Stieglitz here. And we got a little bit of this from Patrick. We saw that there's a whole bunch of sort of different flatfish in the market. Why should farmers be focusing in on the olive flounder for production versus maybe some of the native species in the region?
That's a great question, Ron. And I think we heard today in terms of a number of different advantages for working with the olive flounder. Relatively shorter production cycle when it comes to the species compared to some of the other flatfish species, as well as that established market. And Patrick alluded to that when he was mentioning, not only the species itself, but the different size classes of the fish. And I think when we think of the Atlantic States region in particular, you inherently have a variety of sizes available throughout the production cycle of the olive flounder that can be utilized for servicing some of those different markets. And so building those end uses into your business plan will be key in terms of maximizing the value from your production.
All right. And also, I'd like to open it up to the panel. If they have anything to add to that, feel free to jump in.
Yeah, I mean, olive flounder goes for very high price in comparison to a lot of other flounders. So that's an advantage in itself. There's an established market already at a high value price. So you don't necessarily need to prove that this fish is more expensive or create a fish that isn't expensive, the wild version, and the farm version is a lot more expensive, like Hiramasa, right? Where the wild version is $1.50 or $1 a pound out of Mexico, but the farm version is $10 a pound. So it already has an established market.
So Pat, actually, I want to follow up with you on that. Talking about the market, and this is something I've experienced with this fish, and we know in the US that mislabeling is rampant for various seafood products. So I was at a fairly nice sushi restaurant here in Miami and talking with the owner specifically about flounder. And, it came to my attention that, where were you sourcing your flounder? Well, it was coming out of the Carolinas. So, well, you've got it on your menu as, Japanese flounder, hirame, but that's a totally different fish if you're getting it wild caught from the Carolinas. How do you go about sort of combating that common practice of mislabeling?
Yeah, that is rampant, and definitely, particularly in the sushi trade, very rampant. The Japanese names can be interchangeable between a species, and chefs at a certain point have creative liberty in a way to put it as a specific name. Whereas when I sell the fish to you from the state of North Carolina to South Carolina, I have to call it flounder, right? I have to that's what the FDA requires me. But as a chef, I can put it on as flounder, or I can put it on as summer flounder. I can put it on as olive flounder. They have a choice, right? How you combat that is through branding, and getting someone to acknowledge that your fish is higher value and buy your brand, and request people to put that on the menu. So in the sushi trade, it would be more difficult to do that because they generally don't brand products, but in the white tablecloth market, they will put the brand on the menu. So let's say you build your farm and you call it the Olive Branch Productions or something along those lines. They may put Olive Branch Flounder on their menu, and now you have a brand, and then the consumer recognizes that. And I call it trickle down food economics. So they buy it, they go at a white tablecloth restaurant, they get the Olive Branch Flounder, and then they go to the retail a year later, and they see Olive Branch Flounder at retail, and they go, oh, that was amazing at X restaurant. I'm going to buy it here at the grocery store. That's how you do it. But through branding is really one of the best ways to protect that. You can't tell the chefs exactly what to do, but if you have a story to tell, the chef can now tell that and sell, and waiters can sell that at the table. The final point of sale is really the key. So having a story to tell is something that a chef can use to sell his menu and his dish.
All right. Moving over, Dr. Benetti, thank you for joining us. I wanted to bring up the issue of feeds with you, and we also heard about how feeds influence sort of every step of the process, whether it's your filtration, whether it's the taste of your end product. But so, are there any flounder specific feeds available?
Yeah, good to be here. And just before getting into the feeds, I wanted to compliment what John and Patrick just said about, and you were discussing on why the hirame as opposed to the others. I think we all know This species has been domesticated. This particular species, the aquaculture, has been going on for decades. Whereas ours, the native species, the southern flounder and the summer flounder, the Gulf flounder, we would have to start from scratch. It's just, it doesn't make any sense. Yeah, it has to be a RAS because of biosecurity. It is a non-native species, but it is night and day. I mean, there is no comparison with the other species. Having said that, yes, because it has been raised for so long, for decades, there have been diets that have been formulated to fulfill the nutritional requirements of this species, particularly in Japan and in South Korea, of course. But interestingly enough, just a comment within parentheses, they use fish meal and fish oil from Peru, which brings us to another advantage of being here. The other thing is, again, in Europe, the turbo and other species that are raised, there are diets for the species. They are expensive. They are suitable for the species, no doubt about it. And because of the feed conversion that it exhibits, it would make sense. It would get ahead of any other species. There are diets specifically designed for that. As we all know, we've used some for our trials at the lab. So they're available. They're a phone call away. So the answer is yes, but again, we have to make sure that it is economically viable because they are extremely expensive. Just as an example, the diet that we used from Japan, Higashimaru, right? You guys remember? This was like $3 a kilo or something like that, or even more than that. So it doesn't make much sense.
Yeah, certainly when you get into the importation of diets from overseas, that it really raises the prices.
But having said that, Ron, again, the nutritional requirements of flounder, because of its nature, they're not very much demanding in terms of, it's not like a cobia or a mahi or something like that. So it should be relatively simple to meet their nutritional requirements and come up with a formulation that would work cheaper and better than what's available from importing.
So going over to the chat here, maybe this one might be for Dan Farkas, Charlie's question, considering permitting and the need for waste management of marine RAS facility and considering the high densities all flounder can be grown at, what are options for managing marine waste inland?
That's a great question. There's several potential outlets. So typically what we're looking at doing in an area that is landlocked where you need to capture and process your waste, even if you are going to be able to discharge or inject the cleaned and filtered effluent, you're probably looking most of the time at desiccating or drying the waste. So you're going to go from a mechanical filtration that is going to concentrate the waste, such as a rotating drum. And then you may take that effluent stream and put it through something like a belt press, which is going to assist in pressing the water out and beginning to dry the actual solid waste that is removed before the water is handled. And then what you're also going to do in terms of once it's dried and consolidated, you also have a couple options. So in a lot of freshwater applications where the salt water and chlorides aren't an issue, that solid can immediately be utilized for like a top coat or mixed in for fertilizer. With a saltwater species like flounder, there is some work being done with other marine species looking at rinsing, or before that is, or after it's pressed, basically rinsing and reducing the chlorides or the salts left in the waste so it can be incorporated in to like a topsoil or fertilizer. The other way that a lot of farms still do it is once it's condensed, it's pressed, it's dried, it's going to a landfill, and they have also additional means to mill it into their top coating and actual like organic side, where the chlorides, even though they're at a high level, You know, when you're talking about at a commercial landfill, those levels get diluted drastically. So there are solutions for it, but it has to be planned properly as part of that CapEx and OpEx, because it's not free, or it's not without cost.
Interesting. Staying with you, Dan, and we talk about the CapEx, where do you, what sort of elements of the business do you see the economies of scale coming into play as you increase in size? Is it machinery? Is it equipment? Is it labor? Where do you pick up that value?
Well, you're going to pick it up in a couple different areas. Right off the top, one of the largest areas that we see when we look at the modeling is that staffing, your labor costs, you immediately begin to see benefits as you scale up. Where, you know, for our examples, your team for 100-ton farm, as you expand and grow those modules, is not going to increase anywhere near at the same multiplier as the tonnage, because as the systems get larger and you duplicate them, you can minimize staffing requirements with increased automation, but you are still going to have a uptick, but it's not, if it's 5 for 100, it's not going to be 25 for 500. You may go from 5 to 12 or 5 to 13, depending on how you structure your specific farm. So, you know, that's one of the big areas. The other area, feed. I know people don't think about this all the time, but as you are able to go even from buying feed in like a 50-pound sack to moving to like a super sack or bulk delivery like an auger truck, you can see several percentage points dropped off of your feed cost. And in terms of labor and feed being two of your top 3 costs of operation in an RAS facility, you can see big gains there. And there's also improvements in, you know, as you scale up with construction and things like that, but those are not typically going to be something where you're able to save money as you get larger. As you get larger, the construction becomes more complex typically, and you can't always count on that scale aside from the raw ingredients and the bulk purchasing of things like concrete, steel. You know, you get better deals as you get larger, but there's limits to that.
I'm going to throw this out to the panel. I'm not sure who would be best served to answer this, but the question is, in Jeju, I guess, do they make feed that includes garlic or garlic scrap in it? Any thoughts on this? Marketing aspects, real value there?
I think I can answer that. I've been in Jeju several times. I'm familiar with the industry there. Yeah, they make feeds. They make extraordinary feeds there. It's unbelievable. One of the nicest I've ever seen. It's not either dry or moist. It's like almost like a, you know, like a gel. It's spectacular. I have heard that they use garlic sometimes for treating fish, but not to add value or for anything. But they make, they make like extraordinary fish that look like marshmallow. But they use, again, they use imported fish meal and fish oil, the raw material. They use it from Peru. So we're closer. I think we could do better here in the Americas, you know, in the United States than there.
Ron, I know, you know, the addition of garlic, that's pretty well rooted in also in smaller in aquarium keeping, in terms of when you're feeding nori and seaweed sheets to your algae grazers. There has been some studies showing the benefits of garlic in like small scales in terms of an appetite enhancer and lower mortality, but I don't know how much of that has transitioned into large scale RAS and massive production, as opposed to some of the smaller studies based around aquaria. So, but I know there is some root in fact, at least at a tiny scale and on the aquarium scale, there's been some studies done on that, but I've never heard of it in the large manufacturers, but that doesn't mean it's not there. Obviously, if they're doing that, maybe they're seeing something, but yeah.
Yeah, and I mean, back on the feeds there, Dr. Benetti, you know, while the fish meal is coming from Peru and in Korea and Japan, they're making their own diets. There's still plenty of infrastructure here in the US to produce feeds, correct?
Of course, absolutely. We are definitely not behind them in terms of technology. I would think that we're even ahead. But one must consider that they also use a lot of fresh fish, both in Korea and in Japan. Perhaps over 50% of all feed given to this flounder is trash fish. So it's kind of, we won't do this here. And in a RAS, obviously, that would not be desirable.
So sort of following up from the chat, I think this fits is, what is one of the more inhibiting factors of feed production here in the US?
Yeah, I'll take that one for a second, and then Dan can kind of round it out. One of the biggest things is scale, meaning, when you're in the manufacturing of food business, you're in bulk buying and large commodities, and you're going to be competing against, buyers and corporations such as, Skretting, Cargill, who have massive, in terms of commodities, futures contracts. So really the biggest inhibitor is the scale required to step into even the niche food market. I mean, the costs associated with that. And that's why most farms, until you get well above the 10,000 metric ton side, don't even begin to discuss their own food, even if they have what they feel is an advantageous formula. The cost of buying the raw ingredients, milling it, and successfully administering it while being cost effective is just, the numbers don't add up at a small scale. So
just to complement that, Dan, to me, the main reason behind it's that there are no takers. Why would anybody make feed here? There are no takers. I mean, the cutoff number to justify making or manufacturing feed for any species would be 10,000 metric tons, and we do 0 metric tons of flounder in the United States. So I think, again, if anybody would take the lead, we would follow. Formulations wouldn't be a problem. Ingredients wouldn't be a problem. Is that there are no takers. It's like they ask us, why aren't we producing flounder if we got it down? Because there are no takers. We produce them and we have nothing to do with them.
Yeah. Hopefully that's something that we're going to change very soon. From the chat, I'll take this one, I guess. How old are your brood stock? And how difficult is it keeping them at optimal temperature in Miami? Well, the fish we have here, our current brood stock, were born and raised at the facility. They are approximately 4 years old. And obviously Miami's not their optimal temperature. So we're a little bit warm here for probably 6 to 8 months out of the year. So we actually have chilling capacity on the water at our hatchery. Specifically, there was a lab that was operating here before us that needed a lot of chilled seawater. So they moved to a new building and we inherited their chilling plant. So we've benefited from that. So we have no problem maintaining these fish at optimal temperatures. Then we have a food service question. What are some examples of chilled finfish that started in food service and migrated to retail?
I think the best example of this is barramundi, particularly the US. You never saw barramundi in retail up until about 3 years ago. And you saw it, go into food service with Australis, and they went to food service first. And now they're almost in every single retailer in the United States, to the point where retailers are actually putting this on the fresh counter and putting it in the frozen and private label. So that when something goes private label, that's when it works and it's a viable species for retail, because private label means that the retailer has now trusted the species to put it under their own brand. And something that goes into private label sells 1.5 to 2 times as much as a branded product in retail specifically. So That's the best example in my mind, and Seriola, Yellowtail Hirimosa is on that route, right?
And the barramundi is pretty much 100% a farm product, correct?
Yeah, there's some wild, but it's like tiny.
I guess a little clarification on that chiller, not non-frozen. product.
Yeah, barramundi is fresh, available at multiple retailers in the United States right now. Yeah.
Following up on service side, I guess, is there an established or potential market for 500-gram plate size flounder in the US?
Yes. Yeah, there is. That's how turbot and lemon sole are consumed a lot, plate size fish, and eaten that way at white tablecloth restaurants today. And particularly, I mean, you go to low country, South Carolina, I mean, they're eating most of their flounder whole, and it's mostly deep fried, but there's a whole fish market, most definitely, and it can be created too.
Yeah. Do you think there's potential to continue to develop that sort of whole fish market? It seems like in the case of Bronzino, that's sort of a fish that came out of nowhere, and now it's in every restaurant as a whole fish entree.
Exactly. Yeah, Bronzino, they first grew the fish large to match what people thought was wild, and now there's a huge market for it as plate size fish. And you see it, same thing with striped bass. Striped bass had bigger fish, but now with the farm raised version, a lot of it takes over that Bronzino market for plate size fish. So it's growing. It's a growing thing in the US, and I think consumers are getting more used to seeing whole fish and eating whole fish. So it's growing in popularity to buy and eat a whole fish at a restaurant or even in retail.
And along those lines, when we talk about whole fish and plate size fish, I think, both from the marketing perspective, but also, Dan, from a production and facility standpoint, your production planning, can you speak to that in terms of some of the advantages, as farmers, you want to get rid of the fish sort of as soon as possible, that plate size, but a lot of times, chefs say they want the larger fish, and we see this happen in a number of farm-raised species. Can you speak to that from a facility standpoint or construction standpoint in terms of those dynamics?
So yeah, it's a bit of a balance. Typically, we always look at, and I go back to the term paperfish, and Pat said it best. He's like, paperfish are all the same size, and there's never any different sizes. But in reality, what you end up with is a bell curve of sizes. Even in a well-operated farm with proper grading, you're going to end up with fast growers, you're going to end up with some slow growers, and the bulk of your product is in the middle. Now, again, when you look at what size you're going to harvest, crop turnover, the faster you can move cohorts through, the better off you are, like John was saying. But you also have to make sure that whatever your target harvest size is typically going to be the bulk of the product. And on the low end, you want to make sure that you still have a premium market outlet for those fish. So we're talking about a 500-gram plate size fish. In the case of an 800-gram to 1,000-gram target harvest size, that 500 grams will be the smaller end of your bell curve on the lower side, and there is still an established market for that. So whereas, let's say you base the farm around 500 grams, well, then on the bottom end of your bell curve, you may have 300-gram fish, which are going to be much more difficult to sell. So when you look at what size is your target harvest, you really want to look at not just what's my average size, it's to the left and to the right, do I have good outlets for both? Because otherwise, you may be able to move a lot of product through your facility, but if it's not big enough and you get to these sub-premium outlets for your fish, it can be a drag on your revenue. So, yeah.
I think you nailed it, Dan. Exactly.
Yeah, that's great. Very interesting indeed. Well, I'm not seeing in the Q&A, Ron, I don't know if you,
Yeah, there were a couple more things I wanted to touch on. One in the RAS design and end product consideration. There's certainly concerns over off flavor in recirculating aquaculture and fish that come out of RAS systems. Can you speak to how that is mitigated in the production process?
Sorry, I was muted. Yeah, there's a couple methods. Typically, the traditional method would be where the species, or the target species, in this case flounder, would be removed from the normal production stream and put into a purging system, which would basically be a system that they're held in, they're not fed, there's no biofiltration online, which accelerates and contributes to the off flavor compound accumulation in the flesh and in the water. And you would basically hold those fish for a given period of time. It's different for every species. Pompano, for example, with the metabolism they have, would be different than the flounder, for example, as well as it would be different for salmon. So that's one way, is to take them offline, do not feed them, and also, again, put them in a clean system for a period of time. The other side of this that there's been a lot more research in right now is actually utilizing AOPs, which is a fancy way of saying using the addition of ozone as well as hydrogen peroxide in background doses in the final phase, not necessarily just in a purging system, but also raising ORP, which is a measure of how much ozone is in the water, as well as accelerating the purging process in those purge systems and reducing time in there by increasing ozone as well as hydrogen peroxide, which can help to reduce those off-flavor compounds. But that's a newer side as RAS continues to grow and we continue to learn more about the off-flavor compounds. That will continue to grow in research and the degree of research as well, because also people perceive off-flavor differently. Right. So if there's two people, they may not have the same, and maybe Pat can speak to this. If you put 10 people in a room, they're not all going to taste the same level of off flavoring. That's very specific to that person. Like I know for a fact, me, for example, I've eaten fish that I did not detect stuff, and we give that fish to the same person and they may detect off flavoring. I've seen it happen. So that happens. And there's a lot of research that needs to be done with that. I don't know if Pat can answer that too.
I think, a really good example of this is language. When you look at language and you talk about flavor, flavors and experience, it's not a taste is a sense. And you talk about language and you go to a Japanese chef, and I've been into like true Japanese chef restaurants and sushi restaurants where the chef take a piece of your fish and he chews it for what seems like 30 minutes. And he's sitting there chewing it, and he's tasting everything inside of the fish, from the bitterness of the fish to the sweetness of the fish to all the different parts. And they have words for flavors that we don't. And because we don't have those words, we can't taste them or describe them. And so we're not able to actually taste them. And we may not know why we don't like the fish because we don't have a word for it, for what it is that we're tasting. It's an interesting concept and an interesting thing to look into. But yeah, this off flavor issue is, I think, probably the biggest issue with RAS today, to speak. And I've heard, and I hear whispers out there that there are, and maybe you guys hear these whispers more than I do, but there are feed additives that are being created and designed to add as finishing diets that can neutralize the geosmin and IMB in the product. And that could be another alternative. And whoever gets there first is going to be making a lot of money. That's for sure.
I like the comment in our question is, can we rebrand it as fish decanting? Maybe it's just a simple marketing ploy. And then here for either Dr. Benetti or Dr. Stieglitz. We've got a question about how are students able to participate in this type of research at the university? Has there been any focus on creating artificial coral reefs to be incorporated, I assume, in the production systems?
Well, that's a great question. I'm happy to take that. I think in terms of being able to participate in it, come to the University of Miami, right? And so that's where the Flounder are. But you know, if you're if you're in the area, I think we have many opportunities for workforce training and hands-on experience here, and that's something that, unfortunately, over the past, what are we in year 3 of the pandemic now, has taken a hit in terms of allowing for more hands-on activities. But we're here. You know where to find us. We've included our contact information there. So if it's something you'd like to get involved with, learn more about, please feel free to reach out, and we're happy to set up time for that training and hands-on experience. As for the coral reef portion of the question, I don't think I understand it exactly in terms of how you might.
Yeah, I think that
Maybe you could elaborate on that.
I would interpret it as incorporating it, artificial reef structures into the rearing habitat, maybe, sort of
Such
like
as shelving, maybe.
or
Multi-trophy.
enhancement, you know. That's how I'd interpret it, but.
But yeah, you know where to find us. So we're here. If there are any other questions, now would be a great time to type them in the Q&A. And if not, you know, we set aside a good deal of time here for the workshop. But if there are no further questions, we will wrap it up. We'll give it a minute here. While we see if there are any more questions, I'd like to thank all of our panelists and presenters for being here. And most importantly, thank the Atlantic States Marine Fisheries Commission for allowing this work to take place. Well, I don't see any more questions in the Q&A. So with that, I think we'll close out the workshop, and thank you all again for attending. And please, if you have any other comments or questions, feel free to reach out and contact us, and we'll get back to you. Thanks again.
Thank you all.